Welcome back, students, to another virtual session of statistics. We have in the last virtual session we had solved section E, question number 1, that is 1, 2, 3 in that. This particular video now which we are going to solve is for question number 2. Again, reminding you that this particular section E of exercise 4 is not there in your syllabus. Continuing with the first sum of question number 2, that is find the values by using the tabular method. The first sum, limit x tends to 5, x square minus 3x minus 10 upon x minus 5. Now, by simplifying it, we get x square minus 5x minus 2, plus 2x minus 10 upon x minus 5. So, by factorizing it, we get x minus 5 into x plus 2 upon x minus 5. The similar terms gets eliminated. So, what we get as the final answer is x plus 2. Now, taking the value of x nearer to 5 by increasing or decreasing it is by decreasing 5 minus 0.1 we get 4.9, 5 minus 0.01 we get 4.99, 5 minus 0.001 we get 4.999, and 5 minus 0.0001 we get 4.4 times 9. By putting the value of x in x plus 2, in the function x plus 2, we get 4.9 plus 2, that is 6.9, 4.99 plus 2, that is 6.99, 4.999 plus 2, that is 6.999, and 4.4 times 9 plus 2, that is 6.4 times 9. Now, by increasing the value of 5, we get 5 plus 0.1, that is 5.1, 5 plus 0.01, so we get 5.01, 5 plus 0.001, then we get 5.001, and the last is 5 plus 0.0001, so we get 5.0001. By putting in the value of fx, the function, we get 5.1 plus 2, that is 7.1, 5.01 plus 2, that is 7.01, 5.001 plus 2, so 7.001, and 5.001 plus 2, we get 7.001. So it is clear from the table that when the value of x is brought very nearer to 5 by increasing or decreasing it, the value of fx approaches to when we increase it, it approaches to 7.0001, and when decrease it, it approaches to 6.4 times 9, so it is nearer to 7. So we can say that when the value of x tends to 5, the value of fx tends to 7. So the answer for limit x tends to 5, 3x square minus 3x minus 10 upon x minus 5 is equal to 7. Moving on to the second question, that is limit of x tends to minus 1, 2x square plus 3x minus 5 upon x minus 1. Now here when we simplify it, what we get is 2x square plus 3x minus 5 is equal to 2x square minus 2x plus 5x minus 5 upon x minus 1. When we further factorize it, the following factors that we get is x minus 1 into 2x plus 5. In the denominator, we have x minus 1. The similar terms gets eliminated. What remains is 2x plus 5. So we shall take the value of x nearer to 1 by increasing or decreasing the value. By decreasing the value, in the first column we get 0.9, in the second column 0.99, in the third column 0.999, in the fourth column 0.4 times 9. When we multiply the value of x in the function 2x plus 5, we get 2 into 0.9 plus 5, so 6.8, 2 into 0.99 plus 5, so 6.98, 2 into 0.3 times 9 plus 5, so 6.998. Then the last column, 2 into 0.4 times 9, so we get 6.3 times 9, 8. Now when we increase the value, we get 1.1, 1.01, 1.001, and 1.001. When we multiply it with 2x plus 5, we get 7.1 into 1 into 2 plus 5, so we get 7.2. Then 1 into 0.1, we get 7.02. Then we get 7.002. When the last column, we get 7.002. Here in the first column by mistake it is written 7.1, make the corrections into 7.2. So we can say that when the value of x tends to very clear nearer to 1 by increasing or decreasing its value, the value of fx approaches to 7. That is when x tends to 1, fx will tend to 7. So the answer for limit x tends to 1, 2x square plus 3x minus 5 upon x minus 1 is equal to 7. Moving on to the third sum of this particular section, question number 3. Limit x tends to minus 1, 4x square plus 5x plus 1 upon x plus 1. So we get fx is equal to 4x square plus 5x plus 1. When we factorize it, we get 4x square plus 4x plus x plus 1 upon x plus 1. Further factorizing it, we get x plus 1 as one of the factor and 4x plus 1 as the other factor upon x plus 1. Both the numerator and the denominator x plus 1 gets eliminated, so we get 4x plus 1. Now taking the value of x nearer to minus 1 and obtaining the table, when we decrease the value, we get minus 1.1, minus 1.01, minus 1.001 and minus 1.0001. When we put that in the equation that we got, that is 4 into x plus 1, the value of x, we get minus 3.4, minus 3.04, minus 3.004 and minus 3.0004. In the further action, when we increase the value, we get minus 0.9, minus 0.99, then minus 0.999 and minus 0.4 times 9. So the final answer that we get when we multiply into 4x plus 1, the value of x is minus 2.6, minus 2.96, minus 2.996 and minus 2.996. So it's very clear that when we take the value of x very nearer to minus 1, by increasing or decreasing the value of fx approaches to minus 3. So we can say when x tends to minus 1, y will tend to minus 3. Moving on to the last question of this particular section, question number 2 is limit x tends to 0, 3x minus 1. Now we shall take the value of x nearer to 0 by preparing the table in the following form that is shown on the screen. So by decreasing the value, we get minus 0.1, minus 0.01, minus 0.001 and minus 0.0001. When we multiply that in the equation 3x minus 1, what we get is minus 1.3, minus 1.03, minus 1.003 and minus 1.0003. Now, taking the value of x by increasing the value of 0 by 0.1, we get 0.1, then we get 0.01, then we get 0.001 and finally we get 0.0001. By multiplying it in the equation 3x minus 1, what we get is minus 0.7, minus 0.97, minus 0.997 and minus 0.997. So it is very clear from the table that when the value of x is brought nearer to 0 by increasing or decreasing the value of fx approaches to minus 1, that is when x tends to 0, the y will tend to minus 1. So limiting x tends to 0, 3x minus 1, we get the answer as is equal to minus 1. So with that we complete off with exercise 4 section E, question number 2, all the 4 sums in that. Thank you.